One last time, let's redo this exact same problem we just did using rejection regions. So again, just to kind of slide through this quickly, notice again the claim, the H1, the H0, they're all the same. The information you input is all the same. It's just when you actually get your output from the test that you do not use your p-value, you instead use your, in this case, we're doing a t-test, so we're going to use our t-value, which is 3.77. That is, again, our test statistic. What are you going to test it in? You need to see if it falls inside or outside of the rejection region. How do you come up with the rejection region? Well, first of all, you need to know what kind of picture we're drawing. Well, we're still drawing the normal curve. It's just we're looking at t's now. Well, question is, what kind of tailed test was it? Well, we determined that based on our alternative hypothesis, which had a greater than symbol, so it is a right-tailed test. So let's draw a right-tailed picture. What goes in that right tail or in any of our tails? Well, it's always our alpha, which in this problem was 0.05. Now, when we had z's, we would use the inverse norm function. We're going to be doing t's, though. There will be an inverse t function, or you can use a table. Either way, just like the z values, you always have to have an area to the left. So if the area to the right is what we have, the 0.05, we still need the area to the left. Well, the area to the left then is 1 minus the 0.05, which is 0.95. Now with t's, you need one extra piece of information. It's called your degrees of freedom. It's something when we did chi-squared back in chapter 7 that we also needed. So for t's, you need what's called a degrees of freedom. Remember, that's n minus 1. Well, remember, the n for our problem was 40. So n minus 1 is actually going to be 39. So what we can do is we'll use the inverse t, because we're not doing inverse norm, we're looking for t values now. Inverse t of our area, which was 0.95 to the left. But we just need to give it one extra piece of information. We're going to give comma the degrees of freedom, 39. And then what it will give us when we press enter is our rejection region value, 1.685. That's our t value that creates our rejection region up here, 1.685. Now, what if you don't have the inverse t function on your calculator? Well, there is a t distribution table that will be available to you. If you look across the top, it says, what's the area in one tail? Well, we do have a one-tailed. Well, the area in the one tail from our picture is 0.05. And look, you also need the degrees of freedom, which we said was 39. And if you look where those two overlap, it overlaps in the value that we found using the calculator, the 1.685. That is, again, our t value that makes our rejection region. So even if you don't have the inverse t function in your calculator, you can just use a table. Now that we have the rejection region, what do we do with it? Well, we found out that our rejection region value was t equals 1.685, and we found out our test statistic value was 3.77. So if we put that on the same picture, notice the test statistic here does fall in the rejection region. So if it does fall in the rejection region, what does that mean? It means we're going to reject H0. So as a reminder, what was our H0 and what was our H1? Our H0 was that the mean was less than or equal to 65. Our H1 was that our mean was greater than 65. That was our actual claim. Again, because we're falling inside the rejection region, we're rejecting H naught, which means we'll do the opposite to H1. Its complement will actually accept that, which happens to be our claim, which is why we even care about that. So because we're not failing to do anything, just like before, we're going to see that there is sufficient evidence to do something because we're not failing to do anything. What are we going to do here to H1 where our claim is? We are actually accepting it. So if we want to write this out nicely, we're going to say that there is sufficient evidence to accept our claim that the mean was greater than 65. How did we come up with that? We found our test statistic using our calculator and found out whether or not it fit in our rejection region. Remember our rejection region here is anything greater than our t-value of 1.685. Remember, this 1.685 that creates our rejection region can also be called a critical value. So again, this covers both methods of hypothesis testing for means, and it all is based on whether or not you have sigma as to whether or not you're going to use z's or t's. P-values and alphas are one method, and using rejection regions is our other method. We're going to do this, and we have done this now in 2 different sections. It's really important that you understand and are able to do both methods.